So with the end of the previous lesson, we came to the end of the part of the project which deals with the SOP solver. So rather than going through everything else step by step, I'm going to put the HIP file up and I'll just go through it now to give you an overview of how it works. So let's start with the changes that we've made to the match. I've created some UVs on the match, and I've done this in order to attach the texture, which you can see. And I then use an edit SOP, and I've essentially edited the end of the match to produce this bulbous area at the end. I've then used a sculpt SOP to dent the match to make it a little bit more realistic. We've then got our heat creation as we had before, but in this case I've increased it so that the initial high heat values are everywhere on the bulb of the match. We then send that out to the DOP network, which is essentially unchanged, so that that will spread the heat attribute along the length of the match. We create a group of the points that are hot, i.e. have a heat value above 1, and we then make those dark, except that I start by making them white, and then as the frame number increases, this value will get darker and darker. And the reason for that is to avoid the situation where the colour of this bulb moves straight from red to black over a single frame. We then add some normals and crumple the points as before, and then this is our final node, which is a null, which I've called flame points out. Let's look next at the AutoDom networks, and you'll see that I now have two in the file. I've done this just to logically separate the flame effect and the SOP solver. You can have as many DOP networks as you like, and they'll all be simulated at the same time. I set this up using the control here at the bottom of the screen. It's a bit difficult to see, but if you right click it, you have the option to create a new simulation, which is how I created the flame AutoDom network. And then you can also set the current simulation, and that gives you a choice of all the DOP networks in the network. So what I did here is start off by building this AutoDom network using the shelf tools, and then when I wanted to start using the flame network, I set the current simulation to that network, and as soon as I did that, the shelf tools will use that network as the one that they put their nodes in. Setting the current DOP network doesn't change the fact that both DOP networks will be simulated, it just changes which one is used by the shelf tools. So let's have a quick look inside the AutoDom network, which contains the SOP solver. The only thing that's changed here is the addition of this active value node. Now, an active value node sets a piece of data on our RBD object which controls whether or not the solvers will actually solve it. And the value is set up here at the top. So I've got a little expression in here, $st, which is simulation time, is greater than or equal to 0.25. So the active value is 0 for the first quarter of a second, and then 1 thereafter. So the SOP solver will only start solving this network after the first quarter of a second. And the reason I do that is to allow time for the bulb of the match to burn up before the burning starts spreading down the rest of the match. So after setting up the match, the next step was to set up a source for the flames. And I do this here inside the flame source node, which by default is not displayed or rendered. Let's dive inside. First step is to bring in all of the geometry from the match. Then I select points on the match based on the value of the heat attribute. If it's between 1 and 4, they're a member of this group. Then I take a meta ball and I copy it. Let's change this to hide other objects. I copy it to every point in that group. So we get this bulb end to the match as our initial source for the flame. And then we have a null here which indicates where the flame information is going to be drawn from. And as we play this through, what should happen is that, let's just do that again. What should happen is that the points which in that group, this group here, flame group, will move along the match, and with them the metaball structure that we've constructed. And since this is the source for our flame in our simulation, our flame will also move along the match. So I created the flame effect in 2 steps. First of all, I created a flame container and resized it so it contained the entire match. And then I used a source from object to source the flame from our flame source geometry. And this set up, the shelf tool set up these 2 nodes here, the DSD fire object and the blue cone object. I'm not rendering blue cone fire, so I've got the display node on this one toggled off. And it set up the AutoDom network here. Let's have a look at that. Now, the only nodes that I've changed here are the flame source, where I've ticked the box use deforming geometry so that it takes account of the fact that our flame source is moving around. I've, on the smoke solver, increased the buoyancy considerably so that the flame moves upwards, and on the fire solver I've changed the source divergence, the flame divergence, and the goal flame speed. And I did that through a process of trial and error to create the kind of flame effect that I wanted. But all of these nodes were laid down by the shelf tool. The only one I've added is a uniform force here at the end, which is forcing the flames up and along in the Z direction. And I've added to that some noise, as you can see, and that helps create that variation in the flame as it moves along the match and helps the flames elongate in the Y direction. Next, let's look briefly at shading. The shelf tools set up the blue cone and DSD flame shaders. The clay shader I've just laid down as the basic material for the match, and I've applied a texture map to it. The only shader I've altered is the DSD flame shader, where I've altered the ramp and the alpha ramp to create a flame of the right density for what I wanted, and I've also included the hollow interior. Now, you don't need to resimulate the simulations in order to change the shading. You can use the render view and just tweak these parameters, and the render view will update automatically. So it's a pretty speedy process to adjust this shader to the values you want. Now let's look at our output network. I've got 3 output nodes. The mantra range output node is simply rendering frames to 1 to 200. The mantra output node just renders any frame, and they've essentially got the default mantra node values. The cache flame object is a geometry ROP, and its purpose is to take the flame object, the DSD fire object, and cache it out from frames 1 to 200. I do this because I want to be able to render the simulation separately from simulating it. So here in my network you can see that the fire object has a render null here, which is where the geometry ROP is taking its data, and then I've got a switch here which allows me either to draw the result of this network from the simulation or from file. And since I've got my geometry already rendered out, I'm currently reading it in from the file.